So we want to review some of the characteristics of a normal distribution. And the normal distribution has the following properties. First of all, it's symmetrical. The mean, median, and mode all fall at the line of symmetry for the curve. So here's our mean, median, and mode, which would be represented by x bar here. It is shaped like a bell, peaking in the middle and sloping down towards each side of the curve. And it approaches zero at the extremes. 68% of the data is located within one standard deviation. So that means that 34% of the population is contained between or falls between the mean and one standard deviation below the mean, and 34% lies between the mean and one standard deviation above the mean. 95% of the data is found or falls between the two standard deviations of the mean. So here's two standard deviations above the mean, and here is two standard deviations below the mean. And so the section here between two standard deviations below the mean and one standard deviation below the mean is 13.5%, 34%, as I said before, 34%, and 13.5%. And that makes or adds up to a total of 95%. 99.7% of the data is within three standard deviations of the mean. So virtually all the data is going to be located between three standard deviations below the mean and three standard deviations above the mean. And there's a notation that you'll sometimes see, and this is to describe a normal distribution of variable x. And this is x approximates a normal distribution with a mean and variance. And remember that the variance is the square of the standard deviation. So if this was 5 squared or 25, then the standard deviation would be 5. So now Julie is an engineer who designs roller coasters. She wants to develop a ride that 95% of the population can ride. The average adult in North America has a mass of 71.8 kilograms with a standard deviation of 13.6 kilograms. What range of masses should she be prepared to anticipate? So if we take a look at the normal curve here, well, the mean is 71.8. One standard deviation above the mean will be 13.6 kilograms above the mean, which is 85.4 kilograms. Two standard deviations above the mean, so 85.4 plus another 13.6 is 99 kilograms. So two standard deviations above the mean is 99 kilograms. Two standard deviations below the mean is going to be then 13.6 times 2 minus, 71.8 minus 13.6 times 2, or 44.6. So 44.6 kilograms is two standard deviations below the mean. And to find the value of one standard deviation below the mean, it's going to be 71.8 kilograms minus 13.6 kilograms, which works out to be 58.2 kilograms. So that means that she's going to need to design a ride between 44.6 kilograms, which is two standard deviations below the mean, up to 99 kilograms, which is two standard deviations above the mean, meaning that we know that by the properties of the the normal distribution, that we're going to have 95% of the population between 44.6 kilograms and 99 kilograms, which corresponds again to two standard deviations below the mean to two standard deviations above the mean. If she wants to provide for 99.7% of the general population, what range of masses should she be prepared to anticipate? So in this case, we're going to need to be within three standard deviations of the mean when we select. So three standard deviations below the mean is going to be 71.8 minus 3 times 13.6, which is 31 kilograms, up to 71.8 kilograms plus 3 standard deviations above the mean, or 13.6 times 3, which is 112.6 kilograms. So she'll need to provide a ride for masses between 31 kilograms up to 112.6 kilograms. Now the area under every normal curve equals 1. And in any normal distribution, the percent of data that lies between two specific values is A and B is the area under the normal curve between endpoints A and B. So if 80% of the population lies here, then the probability of a randomly selected individual will have values between A and B, or a data value between A and B, is going to be 80%. Now we can use properties of a normal curve in order to make predictions based on situations where we know the mean and the standard deviation. So if a population has a mean of 50 and a standard deviation of 5, draw a diagram that represents the percent of data that have these values for X. So first of all, greater than 55. So a value greater than 55. Well, greater than 55 is 1 standard deviation above the mean. And if you recall, we have at the mean, that's the 50 percentile. So 50% of the data lies below the mean. 1 standard deviation, remember that 68% of the data lie within 1 standard deviation of the mean, which means that between the mean and 1 standard deviation above the mean, that's going to represent 34% of the data. So that means that there is going to be 16% above this. So 16% of the population will have values greater than 55, or 16% of the population has a value that is greater than 1 standard deviation above the mean. Now, between 40 and 60, well, 40, recall, would be 10 below the mean, which would be 2 standard deviations below the mean, and 60 is 2 standard deviations above the mean. So that means that, in other words, we're asking what percentage of the population would be within 2 standard deviations of the mean. And so here, this is going to be, recall, 95% of the population within 2 standard deviations of the mean, going back to our the properties of the normal curve. Now the probability that X is below 38%, so below 38 is going to be below 2 standard deviations below the mean. So if we're going to use an approximate here, this would be approximately less than 2% of the population would have a value significantly below 2 standard deviations below the mean. So this would just be an estimate. So now, if we want to get more accurate on this, we're going to have to learn about Z-scores and how we can apply those to make better predictions based on distributions that are, or populations that are normally distributed.